Hi, everybody. This is your first video in section 2 of Unit 5. So these sets of videos in this section are all about variables and probability distributions. So we've been talking about, in the previous section, just some basics of probability and dealing really with one variable, or maybe a variable that doesn't change very much, that doesn't necessarily have a distribution. So in these videos, we're going to talk about variables that have that change and have a distribution of values. Now, you've actually been looking at these technically all year, and you just didn't know what they were called um, or recognize them as probability distributions, right? So this first video is going to be pretty short. I'm just going to tell you the basics about probability distributions and talk to you about continuous random variables. And then there's 3 other videos in this section um, about 3 common types of probability distributions, right? So let's go ahead and jump into it here. So the basics here is first we have to talk about what a probability model is. Okay, so a probability model describes all possible outcomes of a chance process and how likely those outcomes are to occur. So, and the likelihood that those outcomes will occur. Okay, right? These probability models describe random variables. Okay, and a random variable is a variable, right, that uh, takes these numerical values that describe the outcomes of a chance process, right? So X, right, an example of a random variable would be the number of correct guesses in a group of, say I asked you 10 questions, right? And you could either get the questions right or wrong. And I would ask you all those questions and we'd count how many you got correct. And so that random variable X could take on many possible values, right? You could get 0 questions right, 1, 2, 3, all the way up to 10, right? So that variable just describes all of the possible outcomes in a chance process. Okay, so a probability distribution gives all the possible values of a random variable as well as their probabilities, okay? And their probabilities, okay? Right? So the example that I have on the slide here is if we were guessing about something, right? Say in the 10 questions that I asked you, right? So that probability distribution would be how it would show how likely it is visually, right, that only you would only get 2 questions right, 3 questions, 4 questions, etc., right? And you can see an example on the screen as well here, where this is the variable here is the number of heads obtained when you flip a fair coin 3 times, right? So they list all of the possible outcomes here, right? So all of the possible outcomes are either 0, 1, 2, or 3 heads, right? So the values here of the variable are 0, 1, 2, and 3. And then the probabilities come from how many ways, right, could that particular value of X occur, right? So there's only one combination that gives you 0 heads, which is tails, 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 right? There's 8 possible combinations total, right? So the probability of that is 1 out of 8. If you add all of the probabilities up, they should equal 1 or 100%, right? Which is kind of a common theme in a lot of these things. I'm hoping you're kind of finding familiar and that's sounding familiar as we go through and learn about all these probability distributions, okay? So there are two types of random variables. In this video, I'm just going to talk to you about continuous random variables because the next video is all about discrete random variables. Okay, so you probably remember from your algebra classes the difference between continuous and discrete. Discrete means that the values in the distribution can only take individual values, like integer values. So the last distribution that we looked at with the number of heads was a discrete distribution, right? Because I can't, the variable x couldn't take on, say, you couldn't get 1.5 heads, right? There are discrete values that that variable can have, right? A continuous random variable will take on values in an interval of numbers, and it can take on any value in that interval, right? So that's the definition of a continuous random variable. It takes on, whoops, I need to click back over to this side, takes on all values in an interval of numbers. Okay, right? So our probability distribution then is described by a density curve, right? So if you think back to unit 3, right, that's when we learned about normal distribution and when we learned about density curves, right? Because continuous random variables can take any value in a certain interval, right? The we can't really use we can't use curves the way that we do with discrete, right, and get actual counts, which means we have to use a density curve, right? So for a continuous random variable, the probability of any event is the area under the density curve. Okay, and above the values of x that make up that event, right? So a perfect example of this is the normal distribution. So like I said, you've actually been doing this for a while. You just didn't know it, right? You didn't know that you were doing it, right? When we did normal distribution problems, I told you that the probabilities, say above a certain value of x or below a certain value of x, or between two values, was the area, right? Say below, above, or above that value, right? So if my x value that I was looking at was here, for example, and I wanted to find the probability that x is less than whatever this number is right here, right? That probability would be this area right here. Because remember, on the y-axis here, this is like, it's all probabilities, right? The x-axis is all the possible values of the variable, and the y-axis is the probability at those individual x values, right? So perfect example of a continuous random variable is that normal distribution, all right? So in the next video, told you this one was going to be pretty short. In the next video, we're going to talk specifically about discrete random variables because we have actual formulas and things that we can use to calculate means and standard deviations and actually figure out what individual probabilities are using some tables, right? So I will see you all in the next video. Bye, everybody.